Hi, everybody. So today we're going to talk about atoms. So we're talking about living things. And in the process of talking about living things, we're going to have to talk about atoms. Why? Now, you may remember that atoms are the building blocks of all things, of all matter. This is matter, right? Made of atoms, right? The table, the computer, everything around us is matter, and it's made of atoms, including living things. But wait, we said living things are made of cells. So which is it? Is it atoms or is it cells, right? Which is it? Well, as it turns out, it's both. Cells are made of atoms. So you, from the top of your head to the tip of your toes, are a walking, talking pile of cells. And each of those cells are made up of atoms. Atoms are tiny, 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 tiny. If you take a look, they're on the very smallest end of the spectrum that we have here. And then atoms are put together in little combinations. That would be 3 atoms right there. And then you could have large, large collections of atoms that might make up something called proteins, or maybe even put it together into a virus, like the coronavirus. This one is a different type of virus than the one that we've seen with all the little spikes on it. But a virus is made up of thousands of atoms. In fact, the smallest virus we know of has 60,000 atoms in it. Okay, so viruses, which are tiny, are made up of tens of thousands of atoms, some of them hundreds of thousands of atoms. Compare that virus to a bacterial cell. Now, a bacterial cell is thousands of times bigger than a virus, and that's tiny compared to a cell, and you're made of hundreds of millions of cells. So we're talking about a living thing being made of many, many, many millions of atoms. Okay, so atoms make up cells. Cells, in turn, are the way atoms are organized to make up a living thing, as opposed to a phone, right? The atoms in the phone are put together in kind of a boring way. You are a walking, talking pile of atoms that are put together in a really cool way. Boring atoms, cool atoms. Are atoms organized into cells, which are organized into tissues that are organized into organ systems, into humans or dogs or cats or other living things. And we'll talk about that later on. But you can see that atoms are a small building block within a living thing. All right, so we're starting with atoms. So atoms come in different varieties, right? Not all matter is the same. A pen looks very different than a phone, right? And a phone and a pen are way different than me. And so we know that there's a lot of different atoms involved here in behaving in very different ways. So there's lots of atoms that we've found in the universe that behave differently. And those different kinds of atoms are called elements. There's a lot of different kinds of elements, well over 100 elements. We've organized them into a table called the periodic table of elements. And we know that we have one that we've nicknamed H. It's a type of element. Its nickname is H. Its real name is hydrogen. It's a type of atom. Find it in our atmosphere. Helium, carbon. We've got all different kinds of elements, different types of atoms that make up the different matter, whether it's phones or living beings, right, or jackets or living beings. We have all these different kinds of elements. This is how we organize them in a chart. All the different kinds we've identified or found in nature. All right, so there are 4 that you should know. We should know hydrogen, that's H. We should know carbon, that's C. Oxygen is O and nitrogen is N. If there's any others in the periodic table that you need to know, I will tell you the name. But on a test, I might just say H and expect you to know that's hydrogen. I might just say C and then expect you to know that's carbon, right? Or oxygen is O or nitrogen is N. If it's any of the others, I will tell you what the name is, okay? So these are combined in different ways. If we combine carbon with carbon with carbon with carbon, we can get something called a diamond. That's very different than if we combine carbon with all the atoms in us, right? In different ways. We've got plenty of carbon in us, and we're nothing like a diamond. We're not hard. We're not kind of translucent, right? We're very different. Carbon in us is organized and connected with different elements than a diamond has. So we have all of these different combinations of elements. And anytime you take two different elements and you combine them together, we call it a compound. So we have different combinations of elements called compounds. And here we have a water molecule. Water is two H's, hydrogen. You should know that by the time we're done with this. H is hydrogen, and an O, oxygen. So there's two hydrogen atoms connected to an oxygen atom, and that makes water molecule. The stuff that you drink out of your water bottle is got H's and O's organized together like this, okay? But it's millions of them, millions of two H's and O's in there. So we can organize those in what's called a molecular formula. Now, molecular formula is written H, because there's H's, hydrogen. There's two of them. So we put H subscript 2, H2, and there's one O. So H2O, and that's what we have there. But that's not really the way it looks. It really is organized into a structural formula. We draw it as a structural formula to show that the H's are each connected to the O, with the O in the middle. Okay, so structural formula is drawn out, shows the way it looks. A molecular formula is the letters and numbers just indicating how many of each thing there is. Now, what about this? Now, remember I said there's millions of these H2Os in a water bottle, right? What if we wanted to represent two of them? We'll take two out of there and we wanted to represent them. So we could possibly have well, there's 4 H's, H4 and 2 O's. So maybe H4O2. That would be wrong. That would not be right. H4O2 is not correct because this is not connected to this. They are separate molecules. If they were hooked together as one molecule, they'd behave completely differently. You wouldn't want to drink it. So it is a different molecule if we have H4O2. Different thing. Here we have an H2O and an H2O, and we want to represent it as H2O, as two H's for every O hooked together. But we also want to indicate that there are two of them, and the way that we do that is by putting a 2 in front. So we've got an H2O, that's this. We've got another H2O, so to indicate that we put a 2 in the front. Structurally, it's going to be drawn as H2O and H2O, and they're not connected to each other. Structural formulas show how they're arranged. Molecular formulas just show what's in it. Oops. Okay, so let's try some. So we have here how many carbons? How many hydrogens? We've got 2 carbons and we have 6 hydrogens. So we're going, and they're all connected together as one molecule. So that is C2. Uh-oh, there's a mistake. I made a mistake in my notes. C2H6. Whoops. So we have C2H6 is the first one. Okay. So what about the second one? What are we going to get for the second one? Well, we have everything connected, so it's just one molecule, so we're not going to have a number in front. We have 3 carbons, and we have 3, 6, 8 hydrogens. Let's see if I did better this time. I did. We have 3 carbons and 8 hydrogens. Okay. Now the next one is tricky. Are they all hooked together? No, these are 2 separate molecules. This has 3 carbons and 8 hydrogens, just like this one. So this is C3H8. And that's C3H8. So which way are we going to write it? Are we going to write C6H16? Or are we going to write 2C3H8s? Well, answer. So we're going to indicate that they're two separate molecules by picking 2C3H8. If we were going to use the first one, it would be connected like that, but it isn't. So it is going to be one C3H8 and another C3H8. So it's going to be 2C3H8. And the last molecule has, if you count them up, 1, 2, 3, 4, 5, 6 carbons, and it has 12 hydrogens, and it has 6 oxygens, and that's a very special molecule that we'll talk about a whole lot, called glucose C6H12O6. You're going to hear about that one a lot. If you hear C6H12O6, we mean all of those particular carbons, hydrogens, and oxygens connected in this particular pattern. All right, so let's practice a little bit. So what do we have there? H2O. We've got 2 H's, 1 O, they're hooked together. How about here? What do we have there? Well, there's still H2Os, there's still water, still stuff you want to drink, but there's 2 of them, millions in here. So we have 2 H2O. This is the stuff you breathe. There's oxygen connected to oxygen, that is O2. And this is the stuff you exhale, right? You actually exhale, you inhale billions of these, exhale billions of those, that is 3CO2. And that is how we, when we're looking at these formulas, we see structural formulas like this. That is how they're written. So that's our first section of chemistry.